Vessels produce a number of pollutants with health effects, primarily nitrogen oxides and particulate matter. And we have used a number of techniques, both on board the vessel, but also in port activities like what we see behind me to measure these emissions. We have tested a number of techniques in order to make sure that vessels use the right fuel and proper emission control as required by regulations in order to fulfill the environmental regulation in Europe. SCIPPER has been a Horizon 2020 project funded by the European Commission, and we want to see in different locations how much pollution from ships is, and also to find solutions in order to decrease the air quality problems caused by shipping.
Ships can emit quite big amounts of certain air pollutants. In particular, they emit nitrogen oxides, but also particulate matter and volatile organic compounds. We can study the effects of ships on air pollution when we use air quality models and emission models. And if we combine these model systems, we can calculate that in coastal areas, ships contribute about 25% to nitrogen oxide concentrations, and it can be even more for particulate matter, because we also have secondary particles that are formed on their way from the ships to the land and also far inland. In SCIPPER, we investigate the contribution of ships to air pollution in harbor cities, in the Mediterranean area, but also in the Northern Baltic Sea area. We do experiments where we measure ship emissions, and we put that into our emission models in order to get the emissions improved. We also improve emissions from ships in ports, because ports are quite heavily influenced by ships also laying at quay in the ports. And there we have to also take into account the buildings and how the flow around the building is and where the pollution is highest. And so we use advanced models in order to study that in detail. Well, SCIPPER uses a really big amount of different techniques, from different observations on board of ships, but also drones to measure around ships. We use very sophisticated observations inside ports, where we look at very, very detailed chemical composition of the ship emissions, and we combine that with modeling exercises. So these models use the observations to make their chemistry mechanisms, to improve their chemistry mechanisms, and then to test whether they can better predict the air pollution from ships in ports.
Important component of shipping pollution are secondary particles, and therefore we analyzed in detail emissions of shipping, looking at the composition of organic species emitted and also composition of inorganic species to be able to in detail illustrate and calculate how the particulate matter is forming. In SCIPPER project we have looked in detail on emissions and especially how the abatement measures, which are set up by the industry to meet the current and upcoming regulation, will affect the emissions in terms of not only the targeted pollutants but also all the other species which contribute to air pollution as such. During the project there were several measurements campaigns where advanced instruments were set up to characterize emissions from shipping in detail. We have several campaigns where we have either on board or in plumes from the ship measured and looked at composition of particulate matter, composition of organic species, of course of emission of the standard emission limited air pollutants as well.
especially for NOx, we are entering tier 3 phase, and SCR systems could be switched off or could malfunction, so it's important to monitor those emissions. In SCIPPER we focused on a number of emissions to monitor on board with sensors. This included, or this was primarily focused on NOx and different forms of particulate matter monitoring, including black carbon. And also in our overall system we defined standard data formats, and we transmitted data via SIS data transmission, satellite data transmission, and developed a central emissions monitoring system. And we think the whole system is important for enforcement. For example, such a reporting could be added to other systems like the MRV.
We have made great progress in the SCIPPER project to understand what's the uncertainty of the methods that we are working on. And we have done a lot of comparison and things like this, and comparison to onboard sampling. So I think we can definitely see ships that are above 0.18% in fuel sulfur content. And we understand quite well now what we should work with in order to get the threshold for the detection a little lower. When it comes to NOx, which is another thing that is interesting to monitor, we have done some great measurements and of maybe 500 ships, and done a lot of comparison. And we understand quite well that we can measure ships that are with engine loads about 50%. We can measure them quite well. Ships that have engine loads which are below are still more tricky, but we have a data set that we're working on in order to see how well we can also measure these ships.
All the emissions, the particulate emissions, are the most difficult to treat because some of the compounds are originally not at all in the particle phase, and some are distributed depending on the temperature on the particle phase or in the gas phase. And then we later have particle formation, what we call secondary aerosol formation, out of the compounds that were in the gas phase. And this has been difficult to be treated, for instance, in the modeling. So what SCIPPER does is we have used the very well thought of experiment with the very latest high-end instrumentation to characterize both the gas phase and particle phase emissions of shipping. What happens with this characterization is that we produce emission factors for different compounds that can be later used in modeling. Of course, we also produce scientific information on what kind of compounds we have and what happens to them in the atmosphere.
To design policies on reduction of shipping emissions and also to see how these policies will develop in the future, the tools we are using are atmospheric dispersion models. And in these models, the main impact which we are studying is impact from particulate pollution, because this has the prominent impact on health. And by studying in detail the processes in plumes, we can better understand how the emissions are producing particles where actually the people live and where the impacts are the largest. So here in SCIPPER we were working based on the data we have obtained from our measurement campaigns, putting them together with the steam emission inventory to characterize in a better way particulate emissions and VOC emissions, and to see how these emissions actually do contribute especially to this delayed particulate matter and to secondary particulate matter on shore.
In SCIPPER, we improved emission inventories for shipping quite significantly. For example, we considered waves, we considered load-dependent emission factors, and we also included new species like volatile organic compounds and ammonia into the emission inventories. We put these emissions then into atmospheric chemistry models, and we didn't only use one model, but we used 5 models to ask the same question: what is the air quality because of shipping in the Mediterranean regions? We got different answers, but they are only slightly different. And so now we can be more sure that we know what the fraction, for example, of NO2 concentrations from shipping is, because several models give us similar answers. In the end, we also try to harmonize the modeling approaches to cover regional scales, continental scales, and also go down to harbor scales with the same similar approach. So we use harmonized emission inventories and harmonized input data for our modeling.
In the SCIPPER project, we are developing a high-resolution air quality model in order to study the impact of ship emissions locally. Some of the attributes that we are studying is the raise of the plume in the city and the penetration on it. We have developed a microscale model in order to see in city scale what is the impact from the ground towards the sky, and to create a model that might be a very useful tool in the hands of the authorities and the policymakers. This model actually can be applied in all ship categories. In the project of Marseille, we are studying the area where we have passenger ships and small cruise ships.
I think in SCIPPER we've done a lot of progress on measuring several of these pollutants with sensors, for example nitrogen oxides, which definitely is already regulated, could be harder regulated, and there could be regulations about having sensors on board, and we have shown that they will work. Other sensors we have tested are, for example, for black carbon, and there are different sensors, and that when those regulations come, that could work also. There still has to be more tests done for sensors for nitrous oxide, for example, which might be a problem with new fuels coming. And for methane, there are sensors available that can be used to monitor the methane slip from natural gas ships.
SCIPPER has measured a great number of vessels in terms of their emissions, has deployed a number of techniques in different places in Europe in monitoring shipping emissions, and has simulated the impact of vessels to air quality in different coastal areas in Europe. We sincerely hope and we believe that the results of the project will be very useful to policymakers in dealing with vessel emissions and improving the air quality in Europe.